This research video shows the development of a low-cost concrete 3D printing system with an aim to make 3D printing of concrete research accessible to a wider research community. The authors are Dr. Aziz Ahmed, Dr. Sadar Ataur Rahman Khan, Mr. Muhammad Saad Sajjad, and Associate Professor Niaz Sheikh. We all are affiliated with the School of Civil, Mining, Environmental and Architecture Engineering at the University of Wollongong, Australia. We gratefully acknowledge the support provided by University of Wollongong's Advancement and Equity Grant Scheme for Research, AEGiS. The aim and objective of this research is to develop a concrete 3D printing system that's low cost and that can be developed almost all the laboratories around the world with a view to advance the 3D printing research. Generally, the 3D printing, concrete 3D printing systems are quite costly, and that's prohibiting or inhibiting concrete 3D printing research due to lack of access to these costly equipment. We want to change that. So we are presenting this low-cost concrete 3D printing system development procedure that we followed so that others can replicate this and advance 3D printing research more and more.
For this video paper, we have designed a mix which was used to print different layers of concrete. So in mix design, there were different ingredients used. And the ingredients includes cement, reverse sand, and bentonite clay. So in first, like we have used cement and sand without using any bentonite, and we have tried almost more than 100 trial mixes, and out of these we have selected 2 different mixes based on using different accelerator and plasticizer with different quantities and with different percentages of these admixture, as well as we have used different types of cement, which means that like when we open the cement bag, so on the first day of opening the cement bag, the properties were different. When we use the same cement bag after 3 days and 5 days, the properties were changing abnormally. So we come up with a result that it would be better if we can use the cement bag which has been opened on the same day, and the same cement bag should not be used which has been opened since 2 days or 3 days. The next stage of this video paper is about the testing equipment that has been used to test the basic properties, fundamental properties of concrete, whether the concrete that is going to be printed is workable, buildable, have desired properties or not. So these include, first of all, we have to measure the slump test by using flow table equipment, and the second is to measure the setting time by using standard record apparatus as per the ASTM standard. And these mixes were prepared in the Hobart mixer, which was mechanically operated with different speeds. And the mix design was ingredients were mixed by using this Hobart mixer as per the ASTM standard.
In this section of the video, I'll talk about how we developed the 3D printing equipment. So we started with a standard grouting gun that most of you would be able to buy from your local hardware store. This grouting gun's equipment components are shown here. Now, these grouting guns are used by concreters to add grouts automatically or more efficiently on difficult to reach locations where you need a lot of grouting. However, we found this to be a very suitable alternative to a 3D printing system for our low-cost 3D printing system that we developed. We also added a frame. In this frame, as you can see, we enabled this threaded system which we can rotate simultaneously from both sides to pick it up at a certain 5 millimeter or so at each turn. That allowed us to control the Z or vertical movement. We also had two pairs of rails that can move on top of each other. At the ground, we put one pair of rails at the desired locations or desired distance that we wanted them to be. On top, we added the other pair, which allowed us to move in X and Y direction easily. On top of it, we added a plyboard by screw connecting them on top of it. So this would be our printing bed. So as you can see, the rails were significantly larger than the printing bed because we needed to account for the X and Y movement. And so only the printing area is quite limited compared to the X and Y rail. So you'll need to make your X and Y rail bigger than your actual printing area for this particular way of printing. Now the grouting gun needs to be secured with a frame to the top of the frame because it's quite heavy, and when you are adding cement all the time, it tends to become heavier and you want to maintain vertically. So manually it's not easy to do. So we added the grouting gun to the frame using this secondary frame that you can see. On top, we also added a pumping system which rotated the grouting gun manual. So instead of holding the button to operate the grouting gun, we were able to automate this process by turning off a switch, and we could control the speed of the motor. That way we can control how fast or how slow we can print, and that's part of our research as well. We tried different nozzle variations, and we found some nozzle variations to work better than others. You will see in the video how these nozzle variations actually worked. We also tried another variations because, as you can see, the grouting gun's feeding system is quite horizontal when it has a small slope when you place it vertically downwards. And that means the concrete doesn't flow very easily. So we tried to add a PVC-based feeding mechanism vertically downward to allow it to move in. However, we found the size of the hole that we were able to create on top of this grouting gun feeding mechanism wasn't enough to allow very quick or good flowability. So we ended up taking it out. So that was not fun to be very operational. To assist the flow, manually we had to temper using a scraper on the side when we are printing. So, and that's one of the limitations of this 3D printing grouting system, where the feeding mechanism is not vertical or very horizontal. So any feeding system that has better slope would actually work better for the second version. We are thinking of modifying it that way.
In achieving 3D printing of concrete, our primary focus revolved around three key aspects: extrudability, buildability, and printability. Extrudability in particular pertains to the seamless flow of the concrete mix throughout the 3D printing nozzle, ensuring smooth operations without the risk of clogs. On the other hand, buildability, a crucial factor in our 3D concrete printing endeavor, refers to the mix's ability to retain its shape autonomously after extrusion. Additionally, it must possess sufficient strength to support the weight of subsequent layer without structural failure. After successfully addressing the factors of extrudability and buildability in our concrete mix, we shift our focus to the printability, which essentially encompasses the overall ease with which we can achieve the desired 3D printing of concrete. In the following videos, we'll take a closer look at our journey in achieving 3D printing of concrete. These clips highlight the crucial aspects, offering insights in our concrete performance during each phase of the process. First is the extrudability. on to the second step, which is a buildability, where we were able to achieve 11 self-supported layers. And finally, the printability that displays the overall success in completing the 3D printing of concrete.
I would like to sincerely acknowledge the support provided by the laboratory staff at the University of Wollongong School of Civil, Mining, Environmental and Architecture Engineering Structural Engineering Lab. Especially our thanks goes to Lab Manager Cameron Nelson and Ritchie McLean Lab Officer, who helped us a lot. And you actually see Ritchie in some of the videos as well. In summary, what we are trying to present in this video is the development of a low-cost 3D printing system that is feasible to be built in most of the laboratories around the world. As you can see, we have used very regularly available grouting gun, framing, and other sensors that you can purchase or you can source locally from any part of the world, most of the part of the world, and put together similar 3D printing system. We have given you a mix design that we found to have worked, and then you can try out to start with that mix design and then improve and build your own mix design. And also we have shown that it is able to actually extrude, build, and print this mix design. So you can be confident that with this equipment you are able to print. However, we also found some limitations, such as the grouting gun's feeding system was too horizontal. You actually needed to hold it at an angle to get it to work best. When you put it vertically, it doesn't work as often as well. So you need to actually temper it. Any modification you can make on that would make your 3D printing even more efficient. We will, once we make more developments, more advancements, we'll create another video to show you our advancements. For now, that's all from us. Thank you.